Okay, so a little note, if I'd say anything controversial, it's with the University of Auckland hat on, and everything boring and dull is, everything staid and steadfast is plant and food research. I've got the massive challenge of convincing a mixed audience of experts in various things that plant biology is a third of the solution to the climate crisis. Why? I mean, this is a massive challenge. The climate crisis, of course, if we don't fight against it, it's going to kick us steadily into the mountains by the next few years, as we've noticed in Cyclone Gabriel and all sorts of things. And I think we can reverse it, but we need to use every tool we have, and plants are one of those tools. Plants fix carbon, which is what we're relying on from fossil fuels. They feed people, so double whammy. And finally, if they make enough money off them, then it replaces a few cows, which we need to do as a country to satisfy our greenhouse gas emission targets. We need a reduction in the number of cows. I'm not anti-cow, I'm a meat eater. I need to be convinced to eat vegetables and fruit, but we can make good coin off it if we get the cultivars right. So I'm going to first describe a little bit about who I am, so you can trust me a little bit more. And then I'll talk about our current research that aims to produce plants that push back against the climate crisis. Here I am, a Christchurch boy, always fascinated by biology, so always impressed by plants, and then Canterbury University, where I was obviously more impressed by girls. Things changed. I moved to Cambridge University, where I did a PhD and met my lovely wife, who is still up the back there, 30 years together, so she's put up with a lot, sorry. Then we moved to Edinburgh for a postdoc, and I produced baby number 1, and she's here at Savagao at the back there. That's not Edinburgh, but it was cold. And then I got a postdoc in the Weizmann, where I connected with Yael's family and tried to learn Hebrew, which went really badly wrong. And I looked really tired because along came baby number 2, Naomi in the back there. We then moved to New Zealand, to Auckland, and I produced baby number... Well, I didn't, sorry, my wife produced baby number 3. I was involved. And the little darlings grew up, the little princesses grew up, and they're all here today, and that's what one of the things I'm most proud of course. But let's talk about fixing the world, okay? Not just for my family, but for everybody else. So I'm going to describe our research to protect our current growing systems, and that's apple in New Zealand, the high-value things, apple, kiwi fruit, berries, things that are good for you, things that the farmer can plant and replace some of those high-value cows, which we need to reduce numbers of. So this is a wonderful report available online. It sets the challenge that we need to feed another 1 billion people by 2050 or go under, and we need to do it without increasing greenhouse gas emissions. So this is a real problem. And this lovely report shows a number of solution scenarios. One of the ones, I put a red bubble around it because that's what I'm most interested in, is spur technological innovation. In New Zealand, we need to use the latest techniques, and we're not. We're regulating ourselves into the organic sector, basically, which is not the solution to the climate crisis. And this graph, one graph from that paper, from that PDF, shows the advantage of growing pulses, for example, legumes that can feed people high protein. You only need less than a hectare to produce 1 million calories, and that hectare produces less than 10 tonnes of CO2. Whereas if you're producing organic beef, you've got to use 13 hectares of land, and it's going to produce 225 tonnes of CO2. So if we could grow our proteins and convince meat eaters like me to eat them, then it's going to be way better for the world that we go towards a more plant-based agricultural system. And if you get it right, you make lots of money. Okay, so this is Zespri's, with permission, Zespri's figures for kiwi fruit. There was a bit of a blip there because of the bacterial disease, PSA. But we're back to producing heaps of high revenue kiwi fruit, $6 billion industry a year, bigger than the wine sector. So kiwi fruit on a relatively small amount of land. So if you get things right, you can make some good money. Now, here's one of the issues that I have. I've taken the existing kiwi fruit vines, which are large things, and they take about 5 years to flower and produce a crop. And I've used CRISPR-based gene editing to make a little plant. I've had to put an arrow here because it's so small and cute. I think it's cute. But the public think it's genetically engineered. It's terrible. It's not. It's just a plant, and it produces it's not a production system. It's just a way to speed up plant breeding. So there's my colleague holding the plant. It's got one fruit on it. That fruit has got 100 seed, more than 100 seed. You plant them out and you get another generation of fast-flowering kiwi fruit. We can breed kiwi fruit way, way quicker, and that's what we've got to do if we're going to keep up with the change in conditions that the climate crisis is forcing us to go through. The other cool thing is that we can publish really quickly. So we're way ahead of the competition globally on kiwi fruit research because I can produce results in a PhD's lifetime really quickly. And I managed to get Kiwi sex on the cover of, which I was really proud of, on the cover of Nature. But we figured out how sex determination occurs in kiwi fruit really quickly because we had this rapid flowering plant. Kiwi fruit have males and female vines. We turned the female vine into a hermaphrodite, and we turned the male vine into a hermaphrodite too. So we went in both directions. So now you don't need bees, or you don't need, you don't need to worry about the climate crisis because you can grow it indoors if you wanted to. My next issue is that this is heavily regulated in New Zealand. This is a genetically engineered plant according to our laws. It's just gene edited, but that's so regulated that we wouldn't be allowed to even, I'm not allowed to eat it. So I've never tasted that fruit. Anyway, I did. In Australia, we'd be allowed to plant it in the ground. It's not regulated. So do I want to go to Australia and move all my research there? No, because I love this country and I want to stay where I am. My family would kill me. So they've got to produce new plant-based options for consumption. And this is my classic exciting result from America. It's impossible meat. So it's made from soybeans and some leg hemoglobin, so the hemoglobin type molecule that we find in legumes. In there, genetically engineered. They're very proud that it's genetically engineered. We can buy it in Countdown at the moment. It tastes of ground beef. It's not a steak. It just tastes of ground beef. And it's made from legumes. It's available in Countdown, but we're not allowed to grow it in New Zealand. It would ruin our clean green image, which I find quite hypocritical and at the least frustrating. The other option that these new technologies do is we can fast domesticate certain species. The potential of plants is massive. There are 12,000 species of flowering plant which are edible. So whoever discovered what particular Amazonian creeper could be eaten, well, that was pretty brave research because a lot of plants are really bad for you. But 12,000 of the flowering plants are edible, and if they could be domesticated, they could kick off some cows that are on our agricultural land. 150 species are cultivated widely, and just 20 species provide 90% of the world's food. So if one of those species went under for some reason, banana, virus, then we'd be in a lot of trouble. We need to rapidly domesticate some of these other species. And this is becoming way, way easier. You just sequence its genome, figure out what its fatal flaw is, and get breeding quickly. Quicker than climate crisis, okay? So I've got a couple of examples there. The pepino, its fatal flaw is it tastes terrible, looks lovely. And physalis, it's a little tomato relative that tastes wonderful, but its fatal flaw is it doesn't produce enough fruit. And we can fix that really quickly with some of these new technologies. My other issue and my other bent these days is begging people in different forums to change some of the regulations, to have this discussion and say, well, gene editing is not that bad. We need to do it. It's one of the tools in our toolbox. Let's change the rules. The rest of the world is changing the rules. The countries in green have no regulations for gene-edited plants. They're not covered by the GMO laws. They're just available to be planted. So you make a little edit in a plant and then you plant it. In Australia, even in England now, the king had to sign the new regulations. He must have been pretty annoyed with that because he's a classic anti-GMO person. But these plants are not GMO. They're gene-edited. They don't have extra DNA in them. They're just different in one particular way. They're just better in some fashion. So the whole lot of the world now, where we're not regulating these plants, but New Zealand stands out there as one, and the EU, as one of the areas where they're sticking with the rules. These have been created by a scientist, not by a plant breeder, therefore they're regulated. Sense the frustration. In Australia, not regulated. All these little plants that are made through little point mutations using CRISPR, not regulated. And in New Zealand, only conventional breeding is not regulated. All the rest of this has to be covered by the Has No Act 1996, which CRISPR wasn't even invented in 1996. An example, feeding the world, right? One little tiny mutation caused by CRISPR changes the number of seeds in barley from 2 rows to 6 rows. So the next issue for that plant would be that it falls over. It has so much yield at the top of it. But we know the genes that make plants shorter, so we'd probably stack in that trait as well. So this is a sort of event that will feed the world, which is not a bad goal, in fact. But in New Zealand, it would be heavily regulated. In fact, you wouldn't be allowed to plant it because it would ruin our clean green image. Sense the frustration. So the frustration is, I've only got about 5 more years before retirement. There's so much to do. Also, the urgency, the 1.5 degrees by 2030. This is happening. If we don't catch up with the climate crisis, make our plants stronger, breed some new ones, replace some cows, feed more people, and not produce greenhouse gas emissions, then this is why I'm saying this is a tool that we have to get into. I love it. I wish I could convince everybody. So thank you very much. Oh, no. That was 20 slides in 10 minutes.
That was impressive. Thank you very much indeed. Are there questions? Yes.
Thank you for that tour de force of your family and your research.
They mixed up.
Very impressive. I think you need more slides. But look, the question I have is one about your plants. Do they pass the taste test?
Oh, well, the kiwi fruit, we've measured everything to do with them. Their sugars are high. They'll taste exactly like gold kiwi fruit. So they're sweet enough. If I was allowed to eat them, I'd report that they taste just like gold kiwi fruit. I did not have a relationship with that fruit. However, our machines can measure everything, and it's genetically identical to gold kiwi fruit, except for one little mutation. So it's unlikely to change its taste. Okay.
So what do you think needs to happen to overcome either the inertia or resistance to altering that 1996 regulatory?
It could be as small a change as a comma inserted in the regulations associated with the Act. That at the moment the judge interpreted the body of regulations that sits with the Act as excluding anything that had been created in vitro. And then they had to say, well, but apart from mutagenesis, which has got a safe history of use since the 1930s. So there are some things that scientists can do in vitro which aren't covered by the Has No Act. So some of the regulations would just have to be tweaked. There'd have to be political backbone, because the Greens would smell trouble, or some of the Greens. Other Greens are saying, actually, this debate about GMO is this big, I say, and the climate crisis is this big. So let's just work with the big gnarly thing first. And a lot of young Greens are saying that too. We're really in line with each other, that they're more worried about the climate crisis than they are about the nuances of how a new plant was generated. So I think education has been proven not to work. So, oh no, sorry, there's some educators in the room. What I mean is that those that don't like GMO aren't sitting there with a vacant hole that you can just fill it with information. If you give them more information, they get even more scared. So my belief is that we need to produce some possibly good examples as a scientist that can actually produce things and show them to people and say, what about this one? So that's the game breaker.
Right, so in the Fellows Forum this morning, we were talking a little bit about the difference between scientific evidence, such as Anne was just giving us a perfect example,
or lack of it.
It's presence or absence.
Yes.
We might say. And also, ChatGTP, and we asked it about how would New Zealand achieve its goals for 2030. And one of the things that ChatGTP, for right or wrong, used as in answering that was about consumer behaviour. So, in part, we've got two elements.
Yes.
Change consumer behaviour to encourage meat eaters to become horse eaters. But how do we deal with the first one? So you've given us a perfect, if you like, a microcosm in your area of those two.
Well, also the early adopters in this country, those that are really enthusiastic to try something new, are given no option. They just, we're not allowed to provide them with something new because it's banned by the Act, effectively. So we're only worried about the 5% of the population that are very upset about this technology. We're not worried about the other 5% that are really keen to get going.
Or the rest of the world
that have moved on.
High-tech food
Yes.
production,
Yes.
which you play a very important part, might contribute.
Yes.
So next year we'll expect you to come back with exactly this. But look, Andrew, thank you very much for that. It's both encouraging and dismaying all at once, but it gives this very clear sense of an urgent agenda.
And that I think science can reverse the climate crisis. We have to. We can't market our way out of it. So we need to use all the tools, engineering, electrification, and plants.